If you have ever wished you could trial a protocol before asking a patient to commit to it, this is for you. In the next few minutes, I'll show you what digital twinning really is, why it matters now, and how to use the Aristotle Plus digital twin output to make faster, more defensible protocol decisions. Digital twinning is the idea of building a living, data-connected virtual model of a real system, so you can test actions in the model before you test them in the real world. In practical terms, a digital twin is a virtual representation that stays linked to the physical system through data, allowing continuous monitoring and simulation of what happens if scenarios. The reason this concept exists is straightforward. In complex systems, intuition is not enough. Engineers needed a way to predict failures, compare interventions, and reduce uncertainty without risking the real system. Some of the earliest roots of this approach trace back to NASA's use of living models and simulators during the Apollo era, where replicated and simulated systems were used to understand risk and evaluate scenarios. Later, the modern digital twin concept was formally articulated in industry contexts like product lifecycle management and emphasizing a persistent virtual counterpart that evolves alongside the physical system. Now, the same logic is moving rapidly into bioscience and healthcare for one reason. Human biology is also a complex system, and we increasingly have the data streams and computational tools to model it. Across the field, digital twins are being explored as a way to support personalized medicine, treatment options, prevention strategies, and virtual testing of interventions. Peer-reviewed review papers and scoping work describe both the expansion of interest and the breadth of potential applications, from cellular models to patient-level decision support. At a high level, the science behind digital twinning is a blend of three ideas. First, you need a model of the system, which can be mechanistic, statistical, or hybrid. Second, you continuously condition that model on real measurements from the individual or system, so the twin is not generic, it is personalized. Third, you run large-scale simulations that explicitly represent uncertainty. Instead of a single prediction, you generate a distribution of plausible futures. You compare interventions based on how they shift that distribution. And the last point really matters because in biology, there's always variability. Measurement variability, day-to-day variability, and context variability. A useful digital twin does not pretend that uncertainty disappears, it quantifies it. And it helps you choose actions that are robust, not just actions that look good in a single assumed scenario. At Theriome, we operationalize digital twinning as a decision support engine inside the Aristotle Plus test. The goal is simple: move from complex biology to a clear, testable protocol more reliably than intuition alone. With the Aristotle Plus, we start by building a patient-specific baseline from two categories of information. First is the metabolite data, the 296 metabolites measured in our panel. Second is the structured context, self-reported demographics, and relevant clinical information. And together, these inputs define the starting state for the patient's digital twin. From there, we run the core engine, simulation at scale. We maintain a curated database of over 1,300 interventions spanning diet strategies, lifestyle changes, supplements, training modalities, and health optimization tools. Then we simulate each intervention not as a single fixed action, but across realistic variations, such as differences in adherence, sequencing, intensity, and combinations with other changes. So in practical terms, the Aristotle Plus runs 1,000 simulated variants across those 1,300 plus interventions, producing over 1.3 million simulation runs. A helpful way to think about this is that we are effectively testing more than 1,300 health strategies, each 1,000 different ways, before a clinician ever commits to a plan. Humans cannot do that. Even expert clinicians are limited by time, cognitive load, and the tendency to overweight the most familiar patterns. Large-scale simulation does not replace clinical judgment, but it can systematically explore a decision space that is otherwise impossible to traverse manually, and it can produce plans that are more consistent, more testable, and less dependent on ad hoc inference. What comes out is not a single guess. The Aristotle Plus generates a ranked set of personalized interventions, clearly classified by categories such as diet, lifestyle, and supplements. And each recommendation is explicitly tied to the subdomains it is targeting, so you can see which physiological constraints the intervention is meant to address. For every recommendation, the digital twin estimates the expected impact as a percent improvement, the projected delta over a defined time horizon, and the relative adherence effort required. These recommendations are not presented in isolation. They are organized into a coherent protocol with guidance on when to retest, so changes can be evaluated against meaningful biological movement rather than noise. Furthermore, the digital twin engine automatically respects each patient's reported food sensitivities, known allergies, and dietary preferences, including those related to religious observance, and systematically checks for potential contraindications between reported medications and protocol recommended interventions such as supplements. The result is a practical, simulation informed plan that balances expected benefit, feasibility, and measurability. And this is also where we want to be explicit about incentives. Theriome does not sell any other recommendations we generate. We do not sell supplements. We do not sell devices. We do not have a revenue incentive to push one intervention category over another. That matters because it keeps the recommendation process aligned with the patient's needs and the modeled impact and not product margins. In short, digital twinning began as a way to manage complexity in high stakes engineering. Today is expanding into bioscience and healthcare because we now have the data and computing to make personalized simulations feasible. And at Theriome, the Aristotle Plus turns that concept into something operational, a patient-specific twin driven by metabolite data and context, evaluated against over 1 million simulated intervention runs, delivering a prioritized protocol and a trajectory you can actually use in clinical practice. If you're a health practitioner ready to move beyond trial and error, bring digital twinning into your practice with the Aristotle Plus. Book your discovery call now at therio.me/train. And the clinics that adopt simulation-driven protocol design first will set the new standard. Don't be the one trying to catch up later.